This is section 4.5 in your textbook, page 189. Before we start, I want to talk a little bit about first of all, what a quadratic relation is. Can anyone tell me what that is, what that means? Something, terminology you need to get more familiar with. I've spoken about it a couple times. Quadratic. Do you know what a quadratic is? We talked about the base of the word quad and where it came from. How it has square, has four sides. Ring a bell, Nicholas?
A relation whose equation is in the form y equals ax squared plus bx plus c.
Okay. That's a good definition from the textbook, and that outlines the standard form of a quadratic relation. There's also two other forms of a quadratic relation, but I just want to know generally what a quadratic is. How do you know it's a quadratic relation? Luigi.
When it's squared, when there's something that is squared, so x squared.
Excellent. Yeah, that's it, right? When the highest exponent is a 2. Okay, that's how you know it's a quadratic relation. Right? If there's a cube there, if it's a 3 or a 4, it's no longer a quadratic relation. Okay, if it's not quite a 2, if it's a 1, then it's also not a quadratic relation. It's a linear. There's another way to tell that it's quadratic using the table of values that you guys have learned. Remember, Andrew? Use the table of values and you check.
Oh, the differences between them?
Yes. How do you know if it's quadratic?
Because they keep like increasing by like square.
No. So if you check the differences, if the first differences are the same, it's...
The 1 through 5.
No, that's a step pattern. David?
If the first differences are different and the second are the same.
Right. If the second differences are the same, it's quadratic. Okay, Andrew? If the first differences are the same, it means it's linear. Okay, good. So now we kind of know what a quadratic is. There's 3 different ways that we can show quadratics. Each one of these can represent the exact same graph. Okay, so don't get confused. You could have a question that is written that looks like this, one that looks like this, and one that looks like this. By the end of this course, you guys are going to be able to convert between these 3. Okay? You're going to be able to change this into this, change this into this. That's the idea with this course. Alright? But the reason why we have 3 different forms, standard form, vertex form, and factored form, is because each form tells us something about the curve at a first glance. Just by looking at it. Okay? Who can tell me what standard form tells us? Just by looking at it. Standard form. What does it tell us? Steven.
Oh, it tells us the x value, the y value gives us 3 points.
No? What x value? What y value?
Like x, so it says x squared, then bx.
No? So there's something specific. Think of the graph. What does this tell us on the graph? There's something. It's the same thing in linear form, actually. Y equals mx plus b. Yeah, Matthew?
The change of slope.
No? Change of slope. Sebastian?
The intercepts?
Yes. Not the intercepts, but the one intercept in particular, which is called the y-intercept, right? Y-intercept is c. Okay, do you get that, Stephen? Because when x is 0, these two terms are eliminated and you're left with c, right? So by looking at the standard form, we understand what the y-intercept is right away. Okay, that's the purpose, that's the nice thing about standard form. The other thing about standard form is we can go from standard form to these 2 forms easily. So sometimes you've got to convert to standard form before you can go to factored form. That's another reason why we have standard form. Okay, vertex form. We just covered this in our last lesson. There's a few things that vertex forms tell us. Ace, give me one thing. Excellent. Good. That's why it's called the vertex. It gives us the vertex, which is HK. All right. What else does it give us, Henry?
It gives us the direction of the graph that it's facing.
Good. So actually, standard form does that too. Oh, you're right. So opens up or down. So this is a value. Right? They all do this because the one constant that you can see between all three forms is A. These are the same number. In every form, they're the same number. Okay? So this also tells us opens up or down. All right? What else does the vertex form tell us? Yeah.
The axis of symmetry.
Excellent. Good. Yes. Axis of symmetry. And what's the formula for that?
Well, isn't it just H?
It is, but there's something equals H. This is a formula. Yeah.
X equals.
Yeah, X equals H, right? Yeah. Okay, because it is an X value. Good. Yeah. Steven?
It tells us the vertical and horizontal translations of the vertex.
Okay, good. So now you're getting into the K value, so and the H value. Good. So vertical plus horizontal translations. Good. Excellent. Anything else? Great.
They also say it, but it tells you the compression of the.
Right, yeah, so compression, good. So with A, so vertical and horizontal compression. Compression slash stretch of the graph. Good, so lots of things vertex form tells us. Finally, factored form. This is what we're talking about today. All right, so I don't expect any of you guys to know this yet, but factored form tells us the x-intercepts. Okay, it tells us the x-intercepts, which are r and s. Very important again to recognize that we have a negative sign here between r and s. So if my formula looks like this, I want to point this out because this is important, guys. You don't want to mix this up. If that's what my formula looks like, I could get rid of A or just say A is 1. My x-intercepts are, positive 3 and positive 1. What does that mean in the graph? That means when my y value is 0, my x-intercepts, where I cross the x-axis, are 1 and 3. Okay, so, and I know it opens up because I know A is positive 1, so I know my graph is going to look something like this. Okay? So see, just from this, I know my graph looks something like that. What I haven't figured out yet is where my vertex is. Okay, but we can also do that with factored form quite easily. So I'm going to put in vertex here. I'm going to put in, so x value of vertex. And what the x value of the vertex is, it's the addition of the two x-intercepts divided by 2. Right? Because it's the middle point. So we know parabolas only go straight up or straight down in grade 10. So we know if they cross the x-intercept at these 2 points, my vertex is going to be the midpoint of those 2 points. So I just add those 2 intercepts together and divide by 2. All right, so in this particular case, in my example, my x value of my vertex would be 3 plus 1 divided by 2 is 2. Okay? So that's the x value of my vertex. So my vertex is going to be 2. And then to find out the y value, Lucas, what can I do? If I have an x value and I have the equation here, how can I find out the y value?
Just plug it in.
Good, just plug it in for x. So we have 2 minus 3 is negative 1 times 2 minus 1 is 1. So negative 1 times 1 is negative 1. So my vertex is actually here. So it would have been more like this. Okay? So my vertex is 2, -1. Okay, so the factored form tells you the x-intercepts, which you can then add and divide by 2, and very quickly you can get the x value of the vertex. David?
How could you tell if the x-intercepts are negative?
Okay, good question. So if the formula looked like this, okay, now David, my x-intercept would be -2 in this case. Okay, so it's the opposite sign that you see in the brackets here. Okay, because in actual reality, I could rewrite this equation that looks like this: -2. Okay, so you can see that to stay consistent with the formula, I keep a negative sign in, my intercept would then be -2. You see that? Okay, yeah.
I don't care if we write it like that.
If you want to write it like this, I don't mind. But you'll get questions where it's written like this. You need to understand that, yeah.
If you get the x value, how would you get the a value?
If you have the x value, how do you get the a value? You would just need one other point
Oh,
on the graph in the same way we did with vertex form. You sub in y and x and you solve for a.
oh,
Okay?
okay.
Any other questions? All right, let's look at, yeah.
Sir, how did you get the -1 for the vertex?
I took 2 and I subbed it into the equation here. All right, so I had 2 minus 3 is -1 times 1. Okay? All right, let's look at a couple examples and then we'll be done. Example 1, this is on page 190. It says, describe the graph of the quadratic relation. So we have a formula that looks like this. Sketch the graph and label the x-intercepts, the vertex, and the axis of symmetry. So all they give us is this, and they want us to sketch it and label all these important points. So, the first thing we should look for when we're in factored form are what, Josh? Good, the x-intercepts. Perfect. So the x-intercepts are going to be -1 and +7. Okay, they're the reverse sign, so we're going to go -1. So here and here. Those are my x-intercepts. And now I know because a value is positive, we're going to look something like this. Right? And I just need to figure out now where the vertex is. So the vertex, I can figure that out by adding my x-intercepts. So r, -1 plus +7, dividing by 2. This is the x point of vertex. The x point of vertex, so we're going to add those two. We get 6/2 is 3. So I know my vertex then is 3, comma, sub 3 into the original equation. So we're going to get y is equal to 2, 3 plus 1, 3 minus 7, equal to 2 times 4 minus 4, -16, -32. Okay, so my vertex is 3 minus 32. So this is actually quite low, right? It's all the way down here. So 1, 2, 3. That's my axis of symmetry. And my parabola looks like this. Okay, where the vertex is here. 3, -32. All right, so it asks for the x-intercepts, which we have, the vertex and axis of symmetry. So we have all three. There are our x-intercepts. You're going to label them. So there's 0, always an x value, so +7, always y value is 0. So your y value, -1, 0. Okay, you're going to label your vertex, and your axis of symmetry here is x equals 3. Remember, your axis of symmetry is the value of h, which is also the x value of your vertex. Any questions? Okay. One more example, that's it. The Dufferin Gate, it's a parabolic arch that is approximately 20 meters tall and 22 meters wide. Sketch a graph of the arch with the left base located on the x-axis 4 units to the left of the y-axis. So, it tells us that the base is located on the x-axis 4 units to the left. So 1, 2, 3, 4. There's my base. And I know that it's 22 meters wide. So from here, I have to go 22 meters. So I already did 4. 1, 2, 3, 4. I need to go 18 more. So 1, 2, 3, 4. So there's my other point. Okay, and that's because it tells me that it's 22 meters wide. And then it says that the arch is approximately 20 meters tall. So we're going to go up 20. Basically the top of the board. Okay, now it says it's 20 meters tall. I have to choose where I should put that 20 meters. Anybody have any ideas? So the two guys. Come on, initiative. Basso, where do you think I should put the 20 meters? So it tells me, Matthew, it tells me that it's 20 meters high. Okay, so I know it goes up to 20 meters, but it doesn't tell me the x-coordinate, but it tells me the base points. And we know it's an arch, right? So where do you think I should put it?
Put it in the y value.
Yeah, the y value is going to be 20, you're right. So it's going to be up here somewhere, but what's the x value is what I'm asking. Am I going to put it over here? Yeah, the middle, right? Because it's an archway, right? Can't put it over here. It's got to be in the middle. So what is that middle point? Tiago, what's the middle point? What's the x value?
It's the two bases added and then divided by 2.
Excellent. Good. So we're going to add those two. So we have -4 plus 18 divided by 2. So we get 7. So we count out 1, 2, 3, 4, 5, 6, 7 here, all the way up to there. So there's our arc. Okay? Good, Diego. So now, it says sketch a graph of the arc with the left base located on the x-axis. Label the x-intercepts and vertex. So x-intercepts here would be 18, 0, -4, 0, and our vertex would be 7, 20. Determine an equation to model the arc. So now our last step, because we're dealing with factored form and we know our x-intercepts, we know it's going to have a format like this. Okay? We just populate those values of r and s. So x minus r in this case, -4. X minus s is 18. So just fixing that -4 to a +4. X minus 18. Now the last thing we need to do is solve for a. So I need to plug in one point for a. What point would I plug in? Steven?
The vertex.
Okay, good. We can plug in the vertex here because we're not in vertex form this time. When we're in vertex form and we plugged it in, what happened was we canceled out our x values and we got just an equality statement. Because we're not in vertex form here, we can try plugging in vertex point. So we have 20 for y. We have 7 for x. negative 121, A is going to be equal to 20 divided by negative 121. So our final equation then becomes, we have A, plug A back into here. Okay? Any questions there? All right. Good. That's the end.